Now for the second solution of this problem, it's way different but more unique. But most importantly, I forgot to put the cubed here. That's on me, but now you know that it's an x cubed there. You probably figured out that pattern. Well, now, since m is greater than or equal to 5, we could just start testing values for when m is at 5. So when m is at 5, there's 24 distinct quadruples, such as the sum of all 4 of these values, such as a1 plus a2 plus a3 plus a4. Any random numbers is congruent to 0 mod 5. Like one of these examples, the main example here is 1, 1, 1, 2, where this is 4 times 3 times 2 times 1 is 24. And why it's like this, or 4 factorial, is because there are this many arrangements of the sequence where a1 can be 4 different values and a2 can be 3 and vice versa, like that. So if we just use our same logic, the next odd number for m is 7. The sum now has to be 0 mod 7. So you can just try and list it out and just find the factorial of that. So d of 7 is 120. Now when m is 9, d of 9 is 336. Since you know, or since q of x or d of m can be arranged for it to be this, except the x's replaced with m's, think of all these values as x's instead of m's. It'll make it a lot easier. We have 3 for now as their digits. M equals 5. We plug 5 in, we get 125 C3 plus 25 C2 plus 5 C1 plus C naught is 24. For a second one, there's going to be a problem. Let me rewrite it better. So for first one, when m is 5, this is 125 C3 plus 25 C2 as plus 5 C1 plus C naught is 24. And well, as you can see here, I'm just going to elaborate further. When you plug in 5 for x, this is x cubed is 125, x squared is 25, and this is just 5 and 0. That's 24. You can then do it again with the 7s. When m is 7, this is just the square cube of 7, 343 C3 plus 49 C2 plus 7 C1 plus C naught is 120. Now for our third one, m is 9. This is 729 C3 plus 81 C2 plus 9 C1 plus C naught is 336. Now, once you realize this 3 is like a big system of equations. It might be hard to deal with as you might need to subtract multiple times. But let's just subtract. Let's just do equation 1, or you subtract the equation 1 from equation 2. This yields, you subtract these two, the first two, and I'm just going to write this out. This is, okay. So this is simply just going to be, well, what is this? 218 C sub 3 plus 24 C2 plus 2 C1 is equal to 96. You can then divide all of that by 2 to get that this is 109 C3 plus 12 C2 plus C1 is 48. As 120 minus 24. Our first one was 96, but since we have that, we get 48. We have this equation, and that's going to be pretty important later on. Okay, now let's do 3 minus 2. This is, well, after that, this is just going to be 193 C3 plus 16 C2 plus C1 is 108. Well, now we have these two equations, which we can then subtract. And, well, these could be numbered 4 and 5, but it doesn't really matter. What matters is that we just subtract the one with the larger number and get the small one with the smaller number and subtract it from that. When you simplify that, you get that this is just 21 C3 plus C2 is 15. 15. Therefore, rearranging C2 is 15 minus 21 times C3. So, when you plug the value of C2 back into, let's say, this equation, well, what do we get? Let's just call this one 4 and this one 5. So we have this value of C, and once we do that, this is just 109 C3. So 109 C3 plus 12 times 15 minus 21 C3. And then you have to add the C1 is 48. Now we can get a value for C1 by subtracting these two terms. So C1 is 143 C3 minus 132. All we want. And, well, since we have this, we can now plug it into the first equation right there. So we have that. So that just becomes 125 C3 plus 25 times 15 minus 21 C3 plus 5 C1 plus C0 is 24. This becomes negative 400 C3 plus 5 C1 plus C0 equals negative 351. So simply, for what we have, C3 is 1. Since we want the value of C1, this is just 143 minus 132, which is our answer of 11 for this problem.